Students, this is the help video for the take-home practice quiz 8.1 through 4. Take as many notes as you'd like. Area of a parallelogram is simply base times height. Remember, height always creates a right angle, so base here would be this side, and there's nothing there, but always keep in mind parallelogram opposite sides are equal, so that means our base is going to be 13, and our height is 14, not 17, because 17 is at a slant. So our area here is 182, check units, meters squared. A rectangle is removed from a right triangle to create the shaded region below. Find the area of that shaded region. So to shaded region, it says it's going to be a right triangle minus a rectangle. And that's going to give us the shaded region. Most important thing here is to actually physically trace everything. So I know if it's a right triangle, that's going to be leg times leg over 2. And a rectangle is simply length times width, or base times height. That's going to give a shaded region. Here's where students have an issue here, is they go for this first leg, if you will, and they go like, oh, the leg is 6. Wait a minute, friends. That is not 6. Because if you physically trace the leg, that's 6 and 10. Always physically trace everything. That's 10, and if I go this way, that's 6 and that's 3, so that's 9 divided by 2. The minus length and width of the rectangle is 3 times 4. Equals 33, and then check units, feet squared. And that would be the area of the shaded region. Always physically trace everything. Area of a trapezoid. You average the bases, one base plus the other base over 2 times the height. Height always creates a right angle. The bases are always the parallel sides. So in this diagram, height does not mean up and down. Our height here would be 8. One base is 3. The other base was 18. Add, divide by 2, times the height, which is 8. So I have here 3 plus that is 21. Divided by 2 gets me 10.5 times 8. And that is 84 yards squared. In the rhombus below, A to B is 10. millimeters. A to E is 6 millimeters. Find the area of the rhombus. Area of the rhombus is going to be diagonal, one diagonal times the other diagonal over 2. Problem is, one diagonal I have is 6 plus 6 is 12. The other diagonal I cannot quite get yet because I'm missing a piece here. So diagonal times diagonal over 2. Take a very close look here. There's a right triangle there, of course, and we have an X. So we're going to go leg squared plus leg squared, hypo squared. So X is going to be the square root of 10 squared minus 6 squared. Which makes X equals 8, if you knew your triplets. So my diagonal is 8 plus 8, so it's 16 right here. Then you go ahead and multiply that out. I'm going to reduce. I'm going to make that into 2 goes into 16 8 times. So my area equals 96, check for units, millimeters squared. Area of a rhombus is diagonal times diagonal over 2. In this case, we're going to draw in the diagonals. Now, once you're on a coordinate grid, yes, you could be using the distance equation, but there's a little bit of a trick here. Because we're completely horizontal and vertical, this distance, if you will, is just from -8 to +2. So that distance from -8 to +2 is 10. This distance is from 5 to -9. So going vertically, that's going to be 5 plus 9, which is 14. So one diagonal is 10, the other diagonal 14 over 2. I get 70. Check for units. You know units, so it's going to just be units squared. A regular octagon has a side length of approximately 3 feet and an apothem of 3.6. Find the area of the octagon. Area of an octagon, or any area of any regular, the key word here is the fact that it is regular, is going to be perimeter times apothem over 2. Our perimeter is 8 sides times 3 each side, and our apothem is 3.6 over 2. So of course, that's 24 times 3.6 over 2. 24 times 3.6 divided by 2, and we get 48.6. 48.6. That does not look like a point. Let's try this again. 48.6 feet squared. says find the area of the regular hexagon with an apothem of 9 millimeters. Write your answer in simplified radical form. That's a hint. No decimals. That's exact form. Area equals perimeter times apothem over 2. So perimeter, walk it around, we're like, wait a minute, I don't have a side length yet, but I do have an apothem. So I can put my apothem here, which is 9. And I know I have 6 sides times some sort of side length, and it's going to be over 2. So the only thing I'm missing here is this side length. Draw our pizza slices. Go around like that. So each pizza slice is going to be 60 degrees. If you look very, very carefully, that means this triangle right here in blue, that's going to be 30, 60, 90. 30, 60, 90. Short leg, root 3, short leg times 2. So our short leg would be here. Short leg to the long leg, root 3, short leg to the hypo times by 2. It reads like this. Something times root 3 is 9. That's how that reads. Something times root 3 is 9. I know my something has to be 3 root 3. Because root 3 times root 3 is 3. 3 times 3 is 9. So my something there is 3 root 3. And if I double that, that means my side length is going to be 6 root 3. Which coming over here, that gets me a side length, 6 root 3. So I have 6 times root 3 times 9 over 2. And you just reduce a little bit. 2 goes in there 3 times. So 3 times 6 is 18. 18 times 9. And my area is going to be 162 root 3, check for units, meters squared. And the circle has a center of O. Radius is 2 centimeters. The central angle is 80 degrees. What is the area of the shaded region? Remember, and it wants it in exact terms. So my sector area is theta over 360 times pi r squared. My theta is 80 over 360 times 2 times 2 times pi. Now we just reduce the daylights out of everything. So the zeros cancel. That's 4 goes in there. 36, 9 times. So our final answer is going to be 8/9 pi. Check units. Units. Centimeters squared. Exact form, fraction with the pi sign. Here we have another circle. The radius is 6 feet. Our central angle is 90. What is the area of the sector? And it's going to be theta over 360 times pi r squared. Our theta is 90 over 360. Our radius is 6 times 6 times pi. Zeros cancel. 6 times 6 is 36. So the 36 cancels here. So our sector area is simply going to be 9 pi feet squared.